Thank you and good afternoon for joining. My name is Deepak Kataria, and I serve as a co-chair at the AI ML working group, which is part of the IEEE Future Networks Initiative. In my day job, I also work as a principal solution consultant, working for projects at AT&T and Ericsson. This is a talk that we are going to co-author between me and Anwar Walid, who co-chairs this AI ML working group with me. So the outline is I'm going to talk about what this initiative is, the Future Networks Initiative. In particular, talk about the AI ML working group, kind of work we're doing. Then we're going to tell you about this full stack 5G network, what we mean by it, what is full stack 5G network, and how do we journey towards a full stack autonomous operation? How do we make that the network, the 5G network, autonomous? What are some of the standards that are in support of full stack operation of 5G networks? And then how we basically can leverage AI/ML based end-to-end full stack management and orchestration framework. Basically a stepping stone towards the goal of full autonomous operation. So that's how I will basically take it. So let me first talk to you about a little bit about the Future Networks Initiative. So Future Networks Initiative is a umbrella initiative focused on basically research and industry advancement to deliver AI/ML vision beyond 5G. Essentially, this particular working group within that initiative will focus on defining taxonomies and states of AI, as well as machine learning. And we want to basically survey what's out there and how we can leverage AI/ML to support those, those initiatives. And basically, there's a group called International Network Generations Roadmap group, which is the INGR, which is the group under the Future Networks Initiative focused on developing these roadmaps. And we publish basically semi-annual technical documents that highlight network technology evolutions over 3, 5, and 10-year horizons. We have about 100+ experts who participate in this. And every 12 to 18 months, we release like a multi-chapter document, which highlights the challenges, roadblocks, with respect to AI/ML. So this is something for you to join free. And basically what we have here is within this particular group, we have many working groups, and AI/ML, as you can see, is one of the working groups in the enablers and users category. And there are other categories for access, for networks, for systems and standards, but we focus on, in this particular working group, on the AI/ML. And some of the work that we do in this area is around end-to-end orchestration and automation. How do we basically provide what is called a zero-touch network and service management, fully operating in closed loop, things like network slicing, network digital twins, a whole bunch of things that we have here. And we also look at AI/ML in a holistic sense. So it's not particular to a given layer, but spreads across all layers. And we look at the range of options to monitor, to learn, to actuate, while we be aware of the performance, security, and reliability of the solution. And we also collaborate with other working groups. One of the key things we're trying to address is how do we close the gap for interpretability, or stated otherwise, explainable AI and trust, because there's a whole lot riding on the results of what you produce as an output from an AI/ML. And do you really trust that? Can you trust it? Can you explain the results? So that's the interpretability and trust gap that we are going to close here, and also mitigate the vulnerability and susceptibility to adversarial attacks. So essentially, if you have models, we have to make sure that they are not exposed, and there is, they're not susceptible to attacks, because if you change the model parameters, then the results that you're expecting from your AI/ML models, will not be what you want, and it could be basically quite to the contrary. So essentially, those things are quite important. And then we also work on this management and orchestration framework, and we leverage the open source where available. And we also work to demonstrate our future. So it's quite easy. Basically, you can join these chapters, or AIML chapter. You can be part of this Future Networks group, and you can add it to your IEEE account, and you can basically be able to get access to all the white papers, right? So let me now tell you a little bit about what I mean by a full stack 5G network. When you look at full stack, what I mean is you have your radio access, or the 5G access portion. You have the 5G edge, 5G core, and your 5G services. Example here is like 5G voice, for example, right? And a large extent of that basically rides on cloud native infrastructure, right? And then you have the RAN and transport, basically, that covers your access and 5G edge portions. And then over all of that is your management and orchestration. How do you basically orchestrate across these multiple domains, and how do you manage elements in these different domains? And then you have a digital BSS layer which sits on top, which basically helps you monetize the network that you are trying to sell to a variety of end users here, right? So it could be manufacturing industry, could be autonomous vehicles, could be drones. So you have a bunch of users here. They could be from different vertical industries. They could be traditional mobile broadband consumers. They could be IoT users, and they all use the stack as you have here. And then you have all these, there's also need to reach public and private clouds, for additional services, that may not be available through the stack, right? Underpinning all of this is the services. So essentially, once you have the stack up and running, you want to make sure that you have the network services, you have all the operational tools that will basically, give you the, in case of a problem, debugging tools and fixing problems and things like that, and the services that you can actually continue to provide, right? So this is sort of, in a broad sense, a 5G stack. So where are we today with respect to autonomous operation? So we're not, so today we're basically, what we have is we have the intelligence which is distributed in different parts of the network. We have some agents, that are running on network functions. You do some local optimization. We are starting to think about how we will approach this using intent-based approach for autonomous networking. You still require a lot of data. You require a lot of labeling, supervision. So now going tomorrow, what we want is, instead of being localized intelligence, we want this intelligence to be distributed in the network. So it's not that you have intelligence in one part of the network and you're hitting up another part which does not have AI. So therefore, your end-to-end is basically limited by what your the weakest link will be in the path. So rather than that, we want to have intelligence distributed in the network. And tomorrow, what we want, so most applications will start in the management plane and business layers, which are easy to make them intent driven, and allowing for automatic conflict resolution. And then basically, this would be, we will have advanced infrastructures with knowledge LCM, right? So when we talk about networks, we talk about user plane, talk about control plane, management plane. So now with AI and ML, there'll be a concept of knowledge plane, and there'll be a knowledge-based lifecycle management. So essentially, this would be, idea would be to integrate the humans in the loop. So make sure that there is an operation delegation and agile collaboration. So basically, you do bulk of the heavy lifting using AI ML, but the final buttons are with the humans to basically actuate those outcomes, right? And the third phase in the future is where we want to be, and that's where our group is focused on. We want the operations to be intent-driven. We want to be a fully autonomous, self-learning, trustworthy, intent-driven operation. And the network should be able to run in zero-touch fashion. And basically, the decision-making can be done by the system. There is autonomous interference, between closed loops. So each loop basically feeds into the other loop, and the other. And these loops, I'll show you how they basically work in tandem, so that you can basically achieve the desired outcome. Now, rather than basically do a ground-up zero greenfield approach, we want to leverage what's happening elsewhere, and we wanted to map that into our stack. So this is a lot of vast body of work that's available. So the TM forum, which is focused on these, they have an autonomous, autonomous networks activity going on in TM forum. There's also the work going on ITU study group 13, where they have this focus group on machine learning for future networks, including 5G. We have the GSMA, which basically is a consortium of telecom operators, and they talk about cross-domain and a layered approach. So you can map those things to the stack. Likewise, if you look at the ORAN Alliance and the service management orchestration framework that they have defined, and in particular, the component of the non-real-time RAN intelligent controller is actually leveraging AI. Likewise, you have management data analytics function, which basically collects a lot of management analytics, which can be used for machine learning and AI. Likewise, you have the ONAP, you have the HC. HC has a group called the Zero Touch Network and Service Management. So there are a lot of areas like that, the ORAN software community here, the NWDAF and 3GPP, which is part of the study area 2, which does network analytics. The Internet Research Task Force is looking at the work around, how they embed AI in networks. And you have these other groups, right? The security groups. So essentially, there's a lot of work already. And if you try to stitch the pieces together in a way that is cohesive, that is holistic, you will be able to approach a target that we have where we want to leverage this, right, in a meaningful way. So, so essentially, what you can do is if you leverage AI and machine learning and machine reasoning. So what we're going to do is we're going to go a step forward. We're going to learn from events and measurements, which we will learn. We will apply a knowledge base expert system to further fine tune that learning and basically arrive at a meaningful outcome. And that decision then will basically drive an execution. And as you execute that actuation, as you execute that, the data collected from that will also be fed back to your events and measurements framework, and that would further optimize your decision making. So whether what you actuated was really, did you get a desired outcome? If it did, that's great. If it did not, what I need to do to basically correct it. So you can think of it, this kind of a paradigm can be leveraged at all levels to drive what is called a closed loop autonomy. The other thing you would also do is that these controls that you have, I try to color code them, so the dark is your cloud infrastructure, blue is your RAN transport, these things, right? Purple is your management orchestration, green is your BSS. These actually operate at different time scales. And they operate different time scales because some actions have to be taken quickly. And, and then some can actually, so those actions that, have to be taken quickly, for which you require inferencing quickly, you cannot spend a lot of cycles learning about, what you need to act on, right? So there will be some inferencing required here. In times, there might be some acceleration needed. So you might be doing it on some CPUs. Over time, you would require GPUs and perhaps, even TPUs if you want to do it hardware, so we can get those kind of loops, right? So what we also do is we also look at when we work with networks, right? Sometimes you have challenge with data, so it's not like your NLP, your natural language processing, or ImageNet type of a situation where you have access to a lot of data and you can use the AI/ML. In the networks, we are presented with a lot of challenges with respect to access to data. So we need to look for algorithms that have high sample efficiency, meaning what can you do with less? Can you work with limited data sets? And further, once you have worked with limited data sets, you also need to work in a faster time scale, right? So here there are several tools that we have at our disposal. We look at the transfer learning. So what you have learned in somewhere else can be applied to with new data somewhere else. Right, you have so I think that allows you from having to train the model from ground up with a lot of new data. You also have multitask learning, where basically the learning basically there is several components that can be shared, and the task specific components can be branched out. So that is another way you can basically do more with the data that you have. And then the meta learning basically allows you to get smart the way you learn, and basically learning to learn these techniques, so you can have few short learning applied, as well as you can actually have synthetic data by working with generative adversarial networks, where you basically work with generators and discriminators, so that basically as the generator is generating data, the discriminator able to filter out bad data from good data, and eventually that loop converges to good data, and that becomes the source of your data that you can use, right? So likewise, there is concept of federated learning, which is also a good fit because you can work with parameter server. You don't have to move data, between your, where, where your model is. You only exchange parameters, and that is actually a big plus, especially if you can deploy such things around edge computes. If you are presented with a problem where you don't have access to labeled data, reinforcement learning is your way to look at, how you can learn online, how you can learn from dynamic data, and basically, get some results. So basically, what I'm telling you here is that there are techniques available at our disposal which we're looking at and applying them to the appropriate use cases. So we can basically, bring in automation and basically bring in techniques, that work in different timescales that work in tandem. And where you have more cycles, more CPU, you can process large data. Where you don't, you process less data, but yet get good outcomes, and how you basically share. Now, once you have all of that, right? Once you have all of that, this particular thing is, once you've deployed it, you might have data issues for which you will go back and basically do your, feature engineering again. You might have issues with models that you may have to fix. So there is a life cycle to it, right? Once you deploy a model ages, and then you have to continuously refresh it. And I think there's some example that we saw in ITU Y.3172, which basically gives a very nice framework, for doing this kind of a thing. And as you can see here, my stack, I put this gray bars here, which is basically saying data lake and pipeline. And I put here model deployment and lifecycle management, right? So once you have this data lake at some place, and then you have a pipeline where these can be consumed by the different layers of the stack, that makes your data aggregation and data management quite simpler. And over here, you have your model management, where you're deploying your model, you're observing the model, you're updating the model, refreshing the model, right, with new data. So this becomes like your continuous kind of a loop. So this is how we want to leverage basically layer by layer. And this is one example wanted to show you that where you have your stack, which you have your access RAN, your radio access network. It could be a fixed network as well. And you have a 5G edge, 5G core, and you're going out to the clouds as well, right, to the hyperscalers. You can actually bring in hierarchical levels of controls. You can bring a local controller, basically, that has the same loop that we talked about, which has the learning and reasoning embedded. And this, what you do is you do data collection. You do data collection, right? And you basically can produce outcomes right here for actuation. Or you can pass that monitoring values and knowledge, delegate. You can delegate the decision making to higher layer, which has access to more information, and you can actually get high level policies and decisions fed to you, and you can actuate basically, essentially based on that, right? So there is a loop that basically progresses upwards, which gets you the benefit of using more and more data, and also the fact that you're able to leverage, compute resources, because you have access to more compute as you go to the higher levels. And then you can basically have them feed the policies and decisions down, and you can basically, augment them at your level and basically take it down this way, right? So this is approach here. Now, these are not new concepts. These are actually, this local controller can very well be what's being defined in the service management and orchestration in the ORAN in the ORAN community. This could be your edge open network automation platform that could be defined in the ONAP, and you have the data collection analytics engine, which is defined over there, right? And this could be your centralized ONAP as well. So essentially what we have is we have constructs that are available to us. It's just a matter of basically putting them together in a layered manner, and so that we can basically achieve the desired outcomes in terms of being predictive about our operations, and also being able to predict, any service slice degradation before it occurs. So, we don't want to be in a situation where we are proactive, where we are actually reacting to failures. We want to be a little bit more, proactive about it, detecting before the failure happens. And when it does happen, and also being prescriptive about when that failure happens. So we want to predict it. When it happens, we want to basically, fix it in a very prescriptive way, so that essentially that you don't see that event in the field at all, right? So that's the kind of area we want to go. And you can see here we have these actuations that are embedded, and they're basically basically acting on policies and decisions that are basically machine learned, augmented, as well as machine reasoning enhanced, so that what you get. And the other thing is that you can also have human in the loop, in the sense of when there are some critical actions that need to be taken, we can have a seamless integration of the human in the loop through a dashboard where you can actually trigger these outcomes. And basically this is the vision we want to be. We want to basically be intent driven, so we basically want to get intent from our customers, and all they do is specify the KPIs that they need for the service, and everything else happens in a combination of machine learning and machine reasoning. Machine learning basically predicts. You further enhance this through the knowledge base. You recommend an action. You monitor what you have, further improve your machine learning, and you further improve your your data that you have, as well as the orchestration for machine learning. And you leverage the combination of data scientists who understand models, as well as domain experts who understand the recommended actions, right? So together, working together with expertise and knowledge base, you basically can get to this intent-based network.